Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about root locus techniques in time response analysis. Okay, and we have certain rules for construction of a root locus. Here our first rule is locate the open loop poles and zeros in the S-plane, and rule 2 is find the number of root locus branches. The root locus branches start at the open loop poles and end at open loop zeros. So the number of root locus branches n is equal to the number of finite open loop poles p or the number of finite open loop zeros z. Whichever is greater, and mathematically we can write the number of root locus branches n as n equal to p if p greater than or equal to z, n equal to z if p less than z. Remember, n equal to p if p greater than z, n equal to z if p less than z. See, rule 3 is identify and draw the real axis root locus branches. If the angle of open loop transfer function at a point is an odd multiple of 180 degree, then that point is on the root locus. If odd number of open loop poles and zeros exist to the left side of the point on the real axis, then that point is on the root locus branch. Therefore, the branch of points which satisfies this condition is the real axis of the root locus branch. Our first rule is locate the open loop poles and zeros in the S-plane. Second rule is find the number of root locus branches. And third rule is identify and draw the real axis root locus branches. Okay, see here the rules for construction of root locus. We have root locus branch. We have 0, -1, -5, and here the in between, it is not a root locus branch. We have sigma and j omega. What is sigma? Sigma, it representing our real axis, and j omega representing imaginary axis. Root locus branch are to be considered, and the in between range is, it is not a root locus branch. Branch is a particular element, particular point, root locus branch. Okay. And rule 4 is find the centroid and the angle of asymptotes. Here, centroid, it is equal to sum of poles minus sum of zeros by n minus m. The angle of asymptotes, it is equal to 180 multiplied with 2q plus or minus 1 by n minus m. See, if p equal to z, then all the root locus branches start at finite open loop poles and end at finite open loop zeros. If p is greater than z, then z number of root locus branches start at finite open loop poles and end at finite open loop zeros. And p minus z number of root locus branches start at finite open loop poles and end at infinite open loop zeros. If p less than z, then p number of root locus branches start at finite open loop poles and end at finite open loop zeros, and z minus p number of root locus branches start at finite open loop poles and end at finite open loop zeros. Actually, the centroid is denoted as sum of poles minus sum of zeros by n minus m. And the angle of asymptotes, it is equal to 180 multiplied with 2q plus or minus 1 divided by n minus m. Here the conditions are p equal to z, p greater than z, and p less than z. Okay, here, see here, we have real axis sigma and imaginary axis j omega. Here we have the branching points -1, -5, and centroid is mid of your branching point, root locus branching point. Here it is centroid equal to -2 for -1 and -5. Here the angle of asymptote calculated with the help of a formula is 300 degree angle, and also we have asymptote with 180 degree angle which is which is the axis of real axis. and we have asymptote with 60-degree angle. We have in the upper side we have asymptote with 60-degree angle. In the lower side part we have asymptote with 300-degree angle, and we have the 180-degree part which is called as asymptote with 180-degree angle. With the help of the formulas of centroid and asymptote angle calculation, we can draw this angles, and we can draw this root locus for our particular system. Okay, rule 5 is find breakaway and break-in points. If there exists a real axis root locus branch between two open poles, then there will be a breakaway point in between these two open loop poles. If there exists a real axis root locus branch between two open loop zeros, then there will be a break-in point in between these two open loop zeros. Write k in terms of s from the characteristic equation 1 plus g of s h of s equal to 0, and differentiate k with respect to s and make it equal to 0. Substitute these values of s in the above equation. The values of s for which k value is positive are called as the breakpoints. Okay. And rule 6 is find the angle of departure and the angle of arrival. The angle of departure and the angle of arrival can be calculated at complex conjugate open loop poles and complex conjugate open loop zeros respectively. And rule 7 is intersection point on imaginary axis. Here substitute s equal to j omega in the characteristic equation and equate real part and imaginary part to zeros separately. And see the breakaway point. For a given example, it is calculated as minus 0.473. I think we'll have a clear idea about how to construct a root locus with the help of rules and calculations. Thank you.